on a triangle. Here's a triangle. Angles are labeled with capital letters, and sides are labeled with small letters. So if we call this triangle, triangle ABC, those angles or those vertices are labeled with capital letters. And then we label the sides with little letters. So in this case, are you okay if I move the C over here and the A over here? Is that okay? Does that wreck your notes? Do you have a pencil? You could erase them. And I'll explain why I changed them after in a second. But for right now, if I labeled them that way, then the side opposite of angle A, I would label this side with a little a. The side opposite of the angle B, I would label with a little b. And the side opposite the big C, I'd label with a little c. In a triangle, if you wanted to say that this is a right-angled triangle, how do we show that? Have you seen that before, where you draw a little box in here? Instead of writing 90 degrees, that box means that this is a 90-degree angled triangle. And if it's a 90-degree angled triangle, okay, what do we call this side? That is our hypotenuse. The angle, the side opposite the 90-degree angle is your hypotenuse. Okay? And then these are our sides, and they change depending on which angle you're talking about. So if I'm talking about, and I'll change colors here, if I'm talking about, I didn't want black, I want green. If I'm talking about angle A, this is still my hypotenuse. The hypotenuse never changes. But if I'm talking about angle A, then we would call this the opposite side. And technically, we should probably say opposite of A, because it's not the opposite side if we're talking about angle B. But in triangles, it just often says, well, what's the opposite side? But we probably need a little bit more definition, because that means we're talking about the opposite side of A. And this side here, B, if we're talking about angle A, that's the adjacent side. And I'll put of A in brackets there. Adjacent in the English language means next to, right? If you're sitting in the cafeteria and you say, your friend probably doesn't ask you, who did you sit adjacent to? They just say, who did you sit next to? Okay? But we use the word adjacent a lot in triangles. Okay? This is called the hypotenuse all the time. The other name for the sides of triangles that are not the hypotenuse, they're sometimes referred to as the legs. So these are a triangle, right-angled triangle has two legs and a hypotenuse. And those legs are just the sides that are not the hypotenuse. Have you seen the Greek letter theta before? Have you done trigonometry where theta's been used? No? So it's a Greek letter. It's pretty easy to make. You make like a zero and draw a line through it. And when referring to angles, if I wanted to talk about angle A, sometimes I would go and put theta in there. So side little a is the opposite side of theta. Side little b is adjacent to theta. And of course, C is the hypotenuse. There, so you remember how to say it. Theta. So in grade 10, we get introduced to ratios. Ratios of what happens when we look at the opposite side and the adjacent side. What happens when we look at the adjacent side over the hypotenuse. And what we're leaning towards is, you might have heard people in math talk about Sohcahtoa. Have you ever heard that being said? That's just an acronym to help you remember these ratios. So in a triangle, the tangent ratio, which is the first one that we're going to look at, which in Sohcahtoa is the toa, is the opposite side over the adjacent side. So this is the definition of tangent in a triangle. Tangent of an angle theta is whatever the length of the opposite side is, divided by the length of the adjacent side. The tangent ratio for the same angle will stay the same no matter how big or how small the triangle is. So if we take out our calculator and first of all, push your mode button, because if you haven't used your calculator, it might either be in radians or degrees. The first thing we want to do is turn our calculator to degrees. You do that by going to degree, and it's flashing and pushing enter, and that will highlight it. To get out of your mode screen, you can push the second button, and above the word mode it says quit, and that pulls you back to this screen. So a very famous angle with tangent is 45 degrees. So if I go to my calculator and I type in tan of 45 and push enter, it tells me the ratio is equal to 1. So my calculator says tan of 45 degrees is equal to 1. So we have to say, well, what does this mean? What's the definition of tangent? The definition of tangent is that tangent of any angle is the opposite side divided by the adjacent side. So could you tell me a number for the opposite side and a number for the adjacent side, so when I divide them, I get 1? Anybody? Two numbers, a number for the opposite side, a number for the adjacent side. Because apparently when I divide these two, the answer my calculator tells me is 1. 2 and 2. Would you agree that 2 divided by 2 is equal to 1? What this means is there exists a triangle, and I'll draw it right here. Right angle triangle. If I make this angle 45 degrees, the opposite side is equal to 2, and the adjacent side is equal to 2. Are there any other numbers you could put in for the opposite and adjacent side so that when you simplify it, it's equal to 1? Or is 2 and 2 the only ones? 6 and 6. Okay. So I could have written tan of 45 degrees is equal to 6 divided by 6. Well, what that means is I could draw, I should have made my 2 ones smaller. I could have drawn this bigger triangle. And if that's 45 degrees, and this side is 6, then this side has to be 6, because the ratio stays the same no matter what size of triangle you have. So now I'm going to draw you another triangle. It's not going to be to scale because I could not draw this on the screen. But if I draw this triangle here, and I tell you that this angle here is 45 degrees, and this side here is 135, obviously not to scale compared to the 6. Could you figure out what that side has to be? Yes. This is the power of trigonometry, because no matter how big or how small that triangle is, for 45 degrees, the ratio is 1. So that means this side here has to be 135. And that is true all the time. What's this other angle in these triangles? It has to be 45. And there's 2 ways now that you can say that that has to be 45. What's one way that you know that that has to be 45? Yeah, all the angles in a triangle have to equal 180. So we could just add them up and say, oh, the other side has to be 45. And there's another way that you know now that it has to be 45. Because if I look at this green angle, what's the opposite side? It's 2. What's the adjacent side to the green angle? It's 2. What happens if I do 2 divided by 2? I get 1. And from our calculator, we just learned that tan of 45 degrees is 1. So if that ratio is equal to 1, you know the angle has to be 45 degrees. Now, most angles aren't pretty like 45. 45 for tan, 45 is pretty. We're going to learn about sine and cosine. All 3 of them have one angle that's pretty. Everything else is ugly. I'm sorry. Let's go to our calculator. Pick a different angle, and you'll see how ugly it is for tangent. 50 degrees? So let's go tan of 50. Oh. Nasty. 1.191753593. Yes. We're just going to use our calculator in grade 10. Okay? So for 50 degrees, it's 1.19. So let's go back here. Let's start a new triangle. New right angle triangle. This time, I'm going to put 50 degrees in here. And boy, I don't remember the rest of the decimal places. 175. I'll just do, oh man. I will just 175. Yeah. 19175. Is that what it was? Yes, there we go. 19175. So there is tan of 50 degrees. Okay? Talking about being particular, I just forgot my units. Did you see where I forgot my units? I didn't have the degree sign. That's going to be very important. Every time you talk about an angle, we have to include the units. It's good enough you just make a little tiny dot, but if you take the time, make a nice little circle, feels good. So tan of 50 degrees is 1.19. Who wants the easy part of the job? I need a volunteer to do the easy part, and they also get to pick the person that has to do the hard part. Nick, you get to do the easy part. Okay? Nick gets to do the easy part. He gets to pick the length of the adjacent side of this triangle. Any value you want. Nice whole number. Just something simple. What do you want this to be? 170. With what our calculator just taught us. Our calculator told us that the ratio of the opposite over the adjacent has to be 1.19. Nick just picked 170 for the adjacent side. So he's saying tan of 50 degrees, our definition says tan is always the opposite side divided by the adjacent side. And he picked 170 for the adjacent side. If we need this answer, I'm going to put an X here. This is what we don't know. We need this ratio, our calculator tells us, to equal 1.19. Should X be bigger or smaller than 170? Bigger, right? Because if we need this divided by 170 to give us 1.19, it needs to be bigger than 1. So the top has to be bigger than the bottom. Because if it was less, then you'd have a percentage or a number less than 1. So Nick, what do you want to, who do you want to try and give an answer for X? Okay? And what we're going to do right now is you just have to guess what you think would be close. You don't have to get it exact.
So I choose a person, you said?
You choose a person, yeah.
Who would like to go?
Ooh, I like Regan's eyes right now. They're saying, you pick me, you're going to get beaten up at lunch. I like those eyes. Okay, I don't want an exact number. Just give me a guess. 200. So her guess is it needs to be bigger, so let's guess 200. 200 divided by 170 is 200 divided by 170 is 1.17. What does that tell us? Should she choose a bigger number or a smaller number? Claire, pick somebody else to choose either a bigger or a smaller number. Can't. Have to pick someone new. Who, sorry? Thurindu? Okay. Are you picking a bigger or smaller number than 200? Bigger. What's your number that you're going to pick? 202. So he thinks it should be bigger. Does that get us closer to 1.19? Ooh, 1.18. Thurindu, pick somebody else. Regan. 202.6. Divided by 170. Ooh, look at all the decimal places he has right. Just off by that value at the end. How could we use our understanding of ratios here? We know it has to be 1.19. We know that this over this, because our calculator tells us this is 1.19175. If you used algebra, how could I get x by itself? Multiply both sides by 170. So if I go to my calculator and I go 170 multiply by, and I'll steal this number from up here for now, we get that 202.598, or 0.6 is really, to one decimal place, 0.6 is perfect. But if we wanted to be more accurate, and so using the value that Nick gave us, we now know from our calculator that this other side has to be 202.6. And that's very powerful. Your calculator has every single ratio memorized, or it can calculate every single ratio for every single angle. 45 degrees, which we started with, was a nice number. It was 1. So we could easily think of two numbers that make 1, 2 and 2, 6 and 6, 7 and 7. Right? We can draw 45, all the different sizes of 45-degree triangles that we'd like. But as soon as we get to another angle, we need our calculator's help. And we need to sort of convert. It's a lot like conversions. We sort of set up a ratio just like we can set up a ratio with conversions. All right, let's continue with some more definitions. Sometimes a question will talk about an angle of inclination. Angle of inclination is when you start from the horizontal, which is like starting from the ground and looking up. That would be your angle of inclination. Maybe add an arrowhead that shows that you start from an angle going up. And then we also have a definition of an angle of depression. I'm going to put an arrowhead here. This is when you start looking straight out, horizontal, and then look down. That would be an angle of depression. So again, I put the arrowhead on this angle to show that it's starting from the horizontal one going down. That would be an angle of depression. So your textbook has this interesting connection that if you want the best amount of energy from solar panels possible, you would like this angle of inclination on your house to be approximately equal to the latitude of where you're living. So living at a higher latitude, you would need a bigger angle. Why is that? Because if you're in the north, the sun doesn't get as high in the sky, and so the rays are coming at a lower angle, so you would want your roof to be steeper so that those angles or those rays would hit more directly, and you would generate more power from your solar panels. Right? If you're right at the equator, you could basically have a flat roof because the sun is like right on top of you beating straight down at the hottest part of the day. Okay? So it's just a neat connection between the angle of inclination and what you would need to have a roof on. And I think the textbook has some questions that deal with this. So to start off with, we're going to practice using our calculator with the tangent ratio. What we do for our work, it says determine the tangent ratio to the nearest hundredth, and then we want to draw a triangle that represents the angle that we chose. So our first one is 20 degrees, so for our work, we'll go to our calculator and say, if I type in tan of 20 degrees, what do I get? Go to my calculator, tan 20 degrees, push enter, I get 0.36, 0.36. And over here, I draw a right angle triangle and I'll try to estimate as best as I can what I think a 20-degree angle looks like. Maybe I drew it a little bit big, but it's not too bad. And on that triangle, you have to label sides that show this. The easiest way to do that is to see, how would I write 0.36 as a fraction? 36 over 100, right? Because we're dealing with hundredths. We could say that tan of 20 degrees, and this is rounded, so I'll use approximation signs here, is approximately 36 over 100. So one possible triangle you could draw for 20 degrees has an opposite side of 36 and an adjacent side of 100. Could you reduce 36 over 100 as a fraction? What does it reduce to? 9 over 25? That means you could draw another 20-degree one where the opposite side was 9 and the adjacent side was 25. And again, a big concept in trigonometry is if the triangle gets bigger or smaller, but the angles stay the same, the ratios stay the same. That if this is 20 degrees, and if this is 36 over 100, if this is 20 degrees, 9 over 25 is the same as 36 over 100. That proportion stays the same. And that becomes a very powerful tool for figuring all sorts of measurements out using triangles. So the first one, if we go to 100ths, we could write that as a fraction, changing a decimal to a fraction, something you did back in grade 9. Tan of 35 degrees, our second one. I'll get you to do this one on your own and draw your own triangles. 45, the next one is going to be easy. You can do that one as well. Tan of 35, on your calculator, did you get that that was 0.70? Okay? If it asks around to the nearest hundredth, you have to include that extra 0. Even though if I want to change this to a fraction, 0.7 is 7 out of 10. Or 70 out of 100. Both of those are the same. So drawing your triangle, I could put 35 degrees there. Then the opposite side would be 7. The adjacent side would be 10. Okay? What I want you to be able to do as well, I want you to draw the 35 degrees up here once. Just so you get the idea that the opposite side changes based on where your angle or what angle you're talking about. In this triangle, the opposite side now is here, is 7, and the adjacent side is 10. Can you see that they're the same triangle? Someone just picked this one up and looked at it and threw it up in the air and then plopped it back down this way? Yes?
Would you prefer us to do one where the opposite side is over there instead of on the bottom?
No, because, I mean, you will find out that you have a preference, okay? My preference is always like this, okay? You could have also drawn your triangle like this, right? And had your 35 degrees here. Then my opposite side is 7, my adjacent side is 10. Do you prefer to put your right angle on the left or on the right, or how you draw it? And there might be someone who says, oh, I like to draw my right angle triangles on an angle like this. Okay, here's my right angle triangle. Here's my 35 degrees. This is still my opposite side. That's my adjacent. There isn't a preference. In fact, if I only got you to draw them one way, as soon as I put a question with a triangle that's curved on a quiz, you'd be like, oh, I can't do this, Mr. JR. I've never seen this kind of triangle before. We want to be able to know that this works with any triangle. So however you draw it, right, you can go, oh, I want to test Mr. JR to see if he can work with upside down triangles. So I'm going to draw my triangle that way and put my 90 degrees there. And I'm going to put my 35 degrees here. Where's my opposite side? This is my opposite. This is my adjacent, because this is my hypotenuse. That's fine. In fact, I do want you to be able to visualize it wherever it is, because I could pick this triangle up, spin it around in my hand, and throw it back on the smartboard, and it might end up upside down like that. But the sides wouldn't change, and the ratios wouldn't change. But it is a good question, because sometimes there are things that we have preferences for, how we write something. 45 degrees, that was our pretty one. That one we've done already. Tan of 45 degrees equals 1. We don't even have to round this one. Notice I used approximation signs for everything else. On this one, it's equal to 1. No rounding necessary. You can draw your right angle triangle with 45 degrees and use anything where the opposite divided by the adjacent is 1. So you could use 1 and 1. Or if 131 is your favorite number and you've been like, man, we don't get to use 131 very often in math, here's your opportunity. 131 and 131. Yes? this is a good question. Because it's exactly 1, there's no need to round. So the question at the beginning says to the nearest hundredth. But because it's exact, you would leave it just as 1. Right? If it was 1.00005 and you actually rounded it, then you would put 1.00. But since it's exact, we would leave it like that. And one more. I hope you're getting the idea of how tangent works. Tangent of 65, we go to our calculator. Tan is 2.14. How would you change that as a fraction? You're in hundredths, so that's 214 over 100. We could draw 65. And this means that the opposite side is 214 and the adjacent side is 100. Now think about 45 degrees being 1 and 1. 45, the opposite and the adjacent are the same. Does it make sense when we had 35 degrees and we got 0.7 or 7 out of 10 that the opposite side, since it's a smaller angle, is less? As soon as it's 45, they're the same. And as soon as you go bigger than 45, well, if I go bigger than 45, I'm going to make my opposite side larger. So we can say that angles less than 45 degrees, the tangent's going to be less than 1. And angles bigger than 45 degrees, like we did with 65 degrees right here, the ratio is going to be bigger than 1. Because now my opposite side is going to be larger than my adjacent side. So we have questions that ask us just for the ratio. This question is not asking us to find out what angle D or what angle F are. It's just asking us for the definition of what is tan of angle D. And tan of angle D, the definition of tangent, is the opposite side divided by the adjacent side. So if we look at angle D, the opposite side would be 3. The adjacent side would be 4. And tan of angle D, this is our final answer. It says determine tan of angle D. We've got tan of angle D by itself on one side, and we say what it's equal to. Finished. Tan of angle F. Tan of angle F is equal to opposite side is 4. Adjacent side is 3. And why don't we do tan of angle E? Because there is no opposite side of the 90. The opposite of angle E is your hypotenuse. And so we never do tan of 90. In fact, if you try it on your calculator, it doesn't like you. Tan of 90. That's what I want to do. No, I don't like you. Right? You just did something that is not allowed against the rules. That is not good. That's like wearing a hat to school. It's bad. So the tangent ratio with opposite and adjacent, those only work for the angles that are not your 90-degree angle. This is where we're going to stop for today.